One of the most common reasons that college students lose points on their exams is they confuse two different formulas for z-scores. One formula standardizes an individual observation into a z-score. The other formula standardizes an average of multiple observations into a z-score. Don't let this happen to you. Watch this video a few times. So the first type of z-score that we are going to be dealing with is the individual observation z-score. So let's say X is normal, and let's say the mean is equal to 2.3, and the standard deviation is equal to 1.6. Now, this is the Greek letter sigma, and this equals the standard deviation. And just to be clear, this is the population standard deviation. And this is the population mean. So let's say we have an observation that we draw from this population. And let's say this observation is equal to 1.4. So we have the underlying population, which I'm going to make sure is a nice capital letter. And we have an observation, which I'm going to make sure is a nice lowercase letter. Now, to get the z-score, the formula is x minus mu divided by sigma, the standard deviation. So all we do is we take the 1.4, which comes from here, and we subtract the population mean, this is a population mean, which is 2.3, and we divide this by the standard deviation, which is 1.6. Now, the way we do this on the calculator is first we hit the parenthesis button, and then we hit the 1.4, and then we hit the minus button, and then we hit 2.3, and then we close the parenthesis with the close parenthesis button, and then we hit the divided by button, and then we hit 1.6, and then we hit the equals button. We take the parenthesis button, and then we take 1.4, and we subtract 2.3. We hit the close parenthesis button, then we hit the divided by button, then 1.6, and then the equals button. And what we get is a z-score of negative 0.5625. So the next type of z-score that we will deal with in college-level statistics classes concern an average of n observations. Now, this is the letter n, and n in college-level statistics is the letter that we always use to represent what's called the sample size. And the sample size is just a fancy term for the number of observations, or the number of numbers. So let's say, again, that X is normally distributed. And let's again say that mu, the population mean, is equal to 2.3. That'll be given in the problem. And let's again say the population standard deviation is equal to 1.6. Again, this will be given in the problem. And let us just say that the sample mean was observed to be 1.4. That means when you took all the observations and you added them up, and you divided by the number of observations, you got 1.4. Now you're going to need the sample size. It must be given in the problem. So let's just say this was based on 11 observations. Let's just say that. So now to get this z-score, we actually have a completely different formula. Here, the z-score formula is equal to x bar, the sample mean, minus mu, the population mean, divided by the population standard deviation divided by the square root of the sample size. Now that looks complicated, but it's not that complicated. So this whole thing, this whole denominator, is called the standard error of the mean. Now, just to let you know, again, this is the standard deviation of an individual observation. And this is the sample size. N is the sample size. So we're going to plug in the numbers, and we have z equals, so x bar is 1.4 minus mu, the population mean, is 2.3. And the standard deviation of an individual observation is 1.6. And this is divided by the square root of the sample size, which has to be given, which is 11. So the square root of 11. So how do you put this into the calculator? So what we do is we take our parenthesis key, and then we go 1.4, and then a minus button, and then 2.3, and then we close the parentheses, and then we hit the divided by button, and then again we hit the parenthesis key, and then 1.6, and then the divided by button, and then the square root button, and then the parenthesis button, and then 11, and then you close that parenthesis, but you have another parenthesis to close. Let me explain that, because a lot of people, they lose credit simply because they don't put it into the calculator right. So this numerator over here, the 1.4 minus 2.3, that's this. This is the numerator. Now this whole thing over here is the denominator. So we have one parenthesis over here for the 1.6 divided by the square root of 11. But notice the square root begins with a parenthesis and ends with a parenthesis. And so we need this one more parenthesis to match this. So we hit the parenthesis key, and then we type in 1.4, and then we hit the minus button, and then 2.3, and then we close that parenthesis. That's the numerator. And then we hit the divided by button, and then we take another parenthesis for the denominator, and then we take 1.6 divided by button, and then we hit the square root, and then we hit parenthesis of the sample size, which is 11, close the parenthesis dealing with the square root, and then we close the parenthesis of the entire denominator, and then we hit the equals button. So when we plug this into the calculator, we get a z-score of negative 1.865, 601445. But we are most likely going to round off this z-score to 2 or 3 decimal places. And the reason why we round this off is because our table of z-scores is probably rounded off. So the table that I use in my classes is rounded off to the nearest hundredth. So I am going to round this z-score off to negative 1.8. Now notice this 5 is a 5 or more. So this 6 gets rounded off to a 7. And this is my final answer.